All right, test review time. So the first one is, our number 2 is on your test work page. It is pretty easy. It is a counting principle. Counting principle does multiplication. So you just got to figure out how many each of these have. I probably zoomed in too much there. Oh no, it doesn't matter on this, so it'll tell us. How many different ways can you make the committee? So it needs three different faculty members. There's 1, 2, 3, 4, 5, 6 male students. 1, 2, 3, 4, 5, 6 female students, 3 parents, and 3 school board members. So what you do to find this answer is you multiply all these. I'm not going to try to do that in my head. Let me get my phone. What was that? 27 times 36? Oh, I did. That should be 972. So on your test work page, I just need to see something like this. You multiply them all together. Shouldn't be that hard to do on the test work page there. All right. I'm going to put these at the top, I think. Next one is on the test work page as well. This is a permutation combination. What you have to be careful about on this one is there's two options. There's an A and a B, right? They could both be permutation. They could both be combinations, or it could be one permutation, one combination, okay? So just because we're going to do one of each on this one does not mean your test will be one of each. The last class got 2 permutations, okay? So on this one, remember the difference. Combination, the order does not matter. Permutation, the order does matter. But we're just going to use the calculator, and you just have to use common sense to determine if it orders or does not matter, or matters or does not matter. So from a collection of 52 store customers, 2 are to be chosen to receive a special gift. How many groups of 2 customers are possible? Does not matter. They're getting the same gift, so the order doesn't matter if you become the first one or the second one. So we're going to do combination. There are 52, combination 2. Oh, by the way I know this is a combination permutation problem, is because I have a total amount and I'm choosing a certain amount out of that. So when you have like 2 numbers that you're looking at like that, and you have a total number and you're choosing those, that tells you it's permutation or combination. So this one is 52 combination 2. Let's go ahead and get our answer in here so we can take a screenshot and get it. That's 1326. The next one is a password. You got a 3-letter password and you got 26 letters in the alphabet. This one is going to be permutation because when you type in a password, the order matters. Like it doesn't count right if you type in the incorrect order, right? So 26 permutation 3. So this is 15600. So for the test work page, all I really need to see on the test work page is you write something like this, 52C2. That tells me that you know what button goes with the calculator, and that is the correct button there. So this one was 26P3. Okay, so again, the combination right here, the order does not matter. And the permutation, the order does matter. Okay. That's how you figure out which button to use. Number 4. This one is, there's 2 of these. This test is not that hard till the end there. So do good on this test. Number cube with 1 through 6 will be rolled once. Write the sample space for it. So the sample space is all possible outcomes. So the sample space would be a 1, a 2, a 3, a 4, a 5, or a 6. So find the event. The event of a 1, 3, or 4 would be a 1, 3, or 4. So you just put it in a set. This is what probability is. When you're finding it this way, the event is all the options that you're looking at divided by all the possible options. So there's 3 out of 6, 3 that we're looking at divided by 6 total. Don't let me miss the next test work page problem. I think it's the next one, right? Yes, this one is on your test work page. So on this one, a spinner with 8 equal slices. What is the 2 slices are blue, 6 are yellow? what is the probability that you land on a red slice? Man, we got an easy one here. So the probability that you ran on a lead slice, there are 0 red slices. So 0 out of 8. And that would be my answer. Just the last class had 3 different colors. Actually, I'll just show you real quick. So like all you're doing on your test page is something like that right there. Just to show you another problem just because. Did I screenshot it though? I did not screenshot it from the last class. So I'm not going to show you. The last class had 3 different colors on their wheel. And it said, what's the probability you get red or blue? So you had to add them up and divide by that. So just a different variation there. So just what you're looking at divided by the total, easy probability there shouldn't be too bad. See, the last class got an easy one on this one too. And y'all get the hard one. So it is nice to do the review multiple times so that you can see all the different variations here. Because like I said, you got a harder one in the last class. Last problem was easier. This one's harder. All right, what's the probability that you draw a black card? So you do have the 52 total up here, so you know the total amount. The black cards is half of them. That's 26 out of 52. I do not believe you have to reduce. Can if you want to, though. What's the probability is a face card? The face cards are these gray ones over here. That would be 12 out of 52. Okay, my face cards are right here. And what's the probability that the card is black or face? Okay, so here's where it gets hard. You have black or a face card. All right, so I have 26 black plus 12 face. What's wrong if I add those up and I get 38? I added these. There are 6 black face cards that I need to subtract out. So it's actually 32 out of 52. Okay, so that is, be careful. The rule for OR, is this one on your test worksheet? So for part C, so this is, so part C, you want to show something like this. You'd show this down here. But the rule for OR is add, but be careful of overlap. The overlap is what they share. So black face cards, like that's the overlap. Because if you add, you might add it twice. All right, this one is experimental versus theoretical. I always like to do part B first just because that's the math part and it makes more sense in my head. So part B is the theoretical number. The theoretical is using math. If I have an outcome that is equally likely to get a 0 through a 9 on it, what's the probability of getting an 8? Well, there would be a 1 out of 8 chance of 1 out of 10 chance of getting that correct, right? There's 10 different options, so 1 out of 10 would be 0.10. 0.1, I don't think it makes you write the 0. 0.10, I like 0.10. Okay, so that's the math. We use the theoretical. Theoretical means to use math. Is this on your test work page too? No, okay. So that means you're using math. The experiment is looking at the chart. Look at chart, okay? Experiment means you go and do it and see if it matches up with the math. It only matches up when you have a big number of trials. Like if I do this 10,000 times, it's going to be pretty close. If I do it 1,000,000, it's going to be really close. If I do it 1,000, it's probably going to be pretty close. But let's see. So what's the probability of getting an 8? So we have 89 out of 1,000 would be 0.089. Okay, so if we rounded that, that would be 0.09. So one is like 9% and one is like 10%. So those are pretty close together. So with a large number of trials, there it may be small. Okay, the difference will be small. So what that is saying is, the more and more you do it, the closer and closer those numbers will get. Okay, and so with 1,000 trials, that is a large number. So you will get pretty close. Those numbers should be pretty close together. Just to show you the other class real quick, y'all get the benefit of seeing the other class stuff. Man, I didn't screenshot that one either. Oh yeah, I did. Right there. No, I didn't. That's a different one. I was kind of bad about screenshotting stuff last class, so you didn't get it. But last class, it was like 51 and 75 because there was only 150 trials, okay? So that says, well, with the small number, as we do more and more trials, that 51 is going to get closer to the 75. So those numbers will get close together. But this one, y'all got a lot of trials. You got 1,000 trials, so the numbers should be pretty close together to start. But if I only did 100, they may be further apart. Okay, this one's on the show your work page, right? Number 8. I'm confused with my numbers now. Yes, this one is on your show your work page. All right, 1 through 8. So we got marbles labeled 1 through 8. Event A is an odd number. Okay, so I would go ahead and write these out. A equals an odd number, 1, 3, 5, 7. B equals number 3 to 6. So 3 to 6 would include 3 and 6, 3, 4, 5, 6. All right, word and is the intersection. It's what they share. So that is going to be, what do they share? They share a 3 and a 5. You want both people to win. You want A and B to win. So it's what they share. How could both people win? Or is union, I always think combine. Combine or bring together. So if I want A or B to win, the numbers that allow A or B to win, you do not actually have to write these in order. I just figured I would. 1, 3, 5, 6, 8. 1, 3, 4, 5, 6, 7. So you just combine them. Okay, because any number that falls in A or B, you combine them, bring them together. The complement of B. So the complement is what is not in B. Not in B. So B is 3, 4, 5, 6. So what would not be in there? 1, 2, 7, and 8. If B is the numbers 3 to 6, then not B would be the numbers that are not 3 to 6. I got a picture. Okay. This one is starting to get into conditional probability. There is a lot of conditional probability, two-way tables to end it. This one, you have a dart lands on 1 through 6. 1, 4, 5, and 6 are gray. 2 and 3 are white. What's the probability that the dart lands on a gray slice? So you just count. There are 4 gray slices out of 6. Okay. What's the probability that a dart lands on a gray slice given, that's the key word there, given that the number is less than 5? So if the number is less than 5, if I already know the number is less than 5, then I know it's not going to be one of those two, right? So that has changed my total amount. If I tell you the number is less than 5, then I'm only looking at 1 through 4. So what's the probability it lands on a gray out of 1 through 4 would be 2 out of 4, okay? When it says given, that changes your total amount. So always look at what's coming after the given. Given that the dart lands on a number less than 5 means I'm only looking at the numbers less than 5. So there's only 4 options and then the gray out of those. Okay. So pay attention to that given. That changes your total amount because you're only focusing on that one condition. Last one on the test work page, I don't believe you even have to. Just doesn't really have anything to do with the problem. All right, on these two-way tables, I always like to just go ahead and write my totals amount. I know that's a little harder for y'all to do when you're on a computer, but all right, the probability that you get a sweatshirt. Probability that you get a sweatshirt would be, there's 36 people out of 60 in a sweatshirt. The probability that you are a parent and a sweatshirt would be 27 out of 60, okay? The probability that you randomly pick a parent given that they're in a sweatshirt or win a sweatshirt or whatever this is. The given. So this line right here means given. So now I'm only looking at the sweatshirt. Whatever's after the given means I only look at that right there. So I know that they have a sweatshirt on. So now what's the probability I get a parent given that I know that they have a sweatshirt on. The probability that they get a parent out of a sweatshirt would be 27 out of 36. Okay? I'm picking the parents out of these sweatshirts because I already know they have a sweatshirt on. So for your test work page, if you want to write this in your own words, the fancy way to say this is, I won't write all of it. The probability you randomly pick someone that is a parent given they are wearing a sweatshirt. Okay? That's the correct way to say it. What's the probability you randomly pick someone and they are a parent given that they are wearing a sweatshirt? Like if you want to write the full sentence, that's fine. But what I'm looking for there is a word given. Probability is a good parent given that they are wearing a sweatshirt. So yeah, just put that in your own words. But remember that it is the column. Like when it says parent given sweatshirt, when you see that sweatshirt after that line, I'm only looking at the sweatshirt column. Okay, and it could give you a row. If they don't, we'll see if another problem we do in a minute gives us a row. But you either focus on that column or that row, whatever comes second. I think this one will do a row. All right. So I think it's like these two-way tables to finish out all kind of different problems here. Probability that a teenager passes the test. Oh man, let's go ahead and total these up so I don't have to do it later. 45, 80, 125, 60, 65. Okay, now let's go back. Probability the teenager passes the test. So if they pass the test, it would be this number right here, right? So that'd be 45 out of 125. I'm going to do that in the calculator because we need the decimal for this one. That is 0.36. Okay. What's the probability that they pass the test given that they took the class? So since it says given they took the class, I'm only looking at this row right here. That's the only thing I'm paying attention to. So now the probability that they pass the test out of the people that took the class would be at 21 out of 60. Is 0.35. Okay, so what this is showing you here is the people that passed the class was about 36%. The people who passed the test was about 36%. The people who took the class and then passed the test was about 35%. So that tells me that the class was useless because the people that didn't take the class, it was independent. It doesn't matter. So we would say, is there evidence a teenager who takes the class is more likely to pass the test? And I would say no, because they are about the same. No, because they are about the same. If those numbers were way different, I would say yes, because B is. And that would show that the class is useful. Well, this shows me that the class is not useful. Just let me take the test. Two more. So let me just, I don't need all that. I'm going to go ahead and total these up just to make it easier for us. That's 105, so that's 127. That's 88. That's 39. Okay. What is the probability that a customer came for lunch and ordered dessert? Lunch and ordered dessert would just be this number right here, right? The lunch and ordered dessert is 127. Everybody good with that? That one's easy. What's the probability that the customer came for lunch or ordered dessert? So the probability that they came for lunch, probability they came for lunch would be 39. Dessert would be 22. So 39 plus 22 would be what? 61. What's wrong with that? Yeah, it's kind of hard to see with my number there, but this is I added, since I highlighted it, it made it purple. I added that 7 twice. So what I actually need to do is subtract the 7 out and then make this 54. Yes. 54 out of 127. Okay. So again, add, but be careful of overlap. And the last one, I believe, is another two-way table. So we got whether they were new customers and what they were doing at the gym here. I'll go ahead and add these up real quick. 21, 50, 50, 59. I don't want to add those up. 31, 55, 67. So that'd be 123. Nope, 113. Better double check. 15 plus 17 plus 24 plus 12 minus 1. Why does it keep doing that? Come on, Cord, you just got to make it one more problem. Okay. So probably the customer was new. Oh my goodness. New or took a boxing class. So new or boxing. So again, it's 67 new, 50 boxing, but I added that 24 twice, right? So 67 plus 50 minus 24 is 93. Oh, I didn't total. Well, I know the total. The total's 180. All right, what's the probability that a customer took a yoga class given that the customer was not new? Given that they were not new means I am only looking at this right here. So given that they not new means I only look at that row, and they took a yoga class. So that would be this number right here. So 7 out of 113. Whatever is second, you focus on that row or that column. That's the only thing you're looking at. Does that make sense? I know they're not new, so I'm only looking at the not new people. And the yoga out of that would be 7 out of 113.